Hello my dear friends, welcome back to in another video. In this video, we'll be studying linked list. So let's take a look at our today's video index. Like what we are going to learn. We are going to learn what is a linked list. We are going to learn how it looks, how to create a linked list, how to traverse it, and we will end up our discussion with the difference between array and a linked list. So before getting into linked list, let's recall what is an array. Array is a contiguous block of memory in which we have stored some data, and that data has a similar kind of data type. It may be integer, it may be a string, it may be a character. So there was a drawback of an array, if you remember, like it requires a contiguous block of memory to store that data. Suppose we are having a large enough memory to store the data, but we are not having the contiguous memory locations to store that data. So we cannot use an array there to store the data. So the solution of that problem is a linked list. We can use a linked list to store that data, because linked list does not store the data in a contiguous memory blocks. It stores the data in a random blocks and it links those blocks using the pointer. So this is what the concept of the linked list is and what is the need of linked list is. Now let's take a look at what exactly a linked list is. Linked list is the improvement in an array. As we discussed, it is a linked collection of data in which each node of the linked list represents some data item. What do you mean by this? It means the linked list, as the name suggests, the list which is linked together. Means what is a list? List is nothing but like if you go to the grocery shop, your mother give you a list in which there are some sort of items are there. If you want to bring some oil, you want to bring a soap, etc. So these are some items. So in the same way, linked list also have some items, and these items are basically called as nodes, and these nodes are connected together. Now let's move ahead. Linked list doesn't require contiguous memory for storing the data. This line we have already discussed. The nodes are allocated dynamically and non-contiguously, and those nodes are linked together using a pointer. So what exactly mean by this line? This means the nodes are allocated dynamically. It means that they are getting allocated randomly at the runtime. If you have studied the concept of the dynamic memory allocation, you will be knowing that what exactly dynamic memory allocation is. If you don't know dynamic memory allocation, don't worry. In this video itself, we'll study what exactly a dynamic memory allocation is and how to do it, so that you will get a better idea to create a linked list. Now what do you mean by non-contiguously? It means that the data items will be allocated randomly. Now what do you mean by data item? Data item is nothing but a node. Node is a compartment in which there are two parts. The first part is the data part, in which you will store the data, and in the next part you will store the pointer to the next node, so that there will be linkage between the next node and the previous node, or you can say the current node. Now all these three lines are clear. So let's go ahead and let's see how linked list looks. The following is the structure of the linked list. Now let's understand the structure of the linked list. Now there is one head which is storing the address of this node, which is a first node in this linked list. So what we learned? We learned that the address of the first node is stored in a head. Now using this single head, we can traverse the complete linked list. Isn't that surprising? Yes, it is. Using a single head, you can completely traverse this linked list. How it happens? We will see that later, but first of all, let's understand how it looks and how it is constructed. This is a node. As I already told, that node has two compartments. The first compartment is a data compartment, and the another compartment is a next compartment, and next compartment is nothing but a pointer to the next node. As you can see, this arrow represents that there is a linkage between this node and this node, A node and the B node. There is a linkage. In the same way, B and C is also having a linkage. B is pointing to the C node. When I say B is pointing to C, it doesn't mean that the complete node is pointing to this. the pointer section, this section, this next section has a it's basically a pointer to the next node. So this is basically pointing to this node. In the same way, now at the end, since there are no nodes left in the to store the data, the last node will point to null. It means basically it doesn't mean anything, it doesn't point to anywhere. It means it simply contains a null, it contains a 0, it doesn't point to any another node because there are no nodes. So this is how linked list looks. And now we can compare the linked list with the real world example like our train. We can see that train has an engine, which we can assume that it is head of the linked list. Now this head is pointing to A. It basically means like head is having address of the first node. This is A is our first node, and its address is stored in this head. Now A is pointing to B. As we can see, there are linkage between the all the bogies of the basically a train. So A is pointing to B, B is pointing to C, C is pointing to D, and so on. At the last, this last bogie points to the end. It means that it doesn't point to anyone, and this basically this represents the end of the linked list. As also we know that in the real world the cross represent the end of the train. So in the same way, it this represent the end of the linked list. These all are nodes. This is a head, and this is basically the end, which we represent using a null or a cross. So now let's code. Let's get into VS Code and see how linked list is created and traversed. Now this is my VS Code. Now let's start coding a linked list. How to create it, and let's see how to traverse it. So first of all, I'm including a IOStream file. Then using namespace std, then our main function, which is very necessary, then our return 0 statement. Now as we have already discussed about the node concept in our prerequisite video, like how to create a node, but in this video we'll take a deep look at it. Basically, what is a node? Node is nothing but a user defined data type. Why it is a user defined data type? Because you can see that node is having two compartments, the data compartment and the next compartment. And in our C++ language or in any other language, we are not having a pre-implemented data type which has this type of two compartments. The first is a data compartment, and the another will be a node pointer type of compartment. So we need to create it by our own. So yeah, we are going to create it using the class. We'll give it a name node, and as I already told you in the prerequisite video that we need to give a semicolon when we declare a class. So I have already given a semicolon here. So there is a need of giving a semicolon here at the end of the class. Now let's create two variables, because there are two compartments. The first one is the data compartment, and we are declaring the data compartment of type integer. The another compartment is a node pointer compartment, node next. So it will point to the next node. So this is basically this item, this node structure. So now with the help of this, we also need some constructor so that we can initialize the data part and the next part. So I'm just creating the constructor here. If you don't know what is constructor, let me give you a brief introduction about the constructor. Constructor is nothing but a special kind of function which is used to store the data, or which is used to initialize the attributes of a class. So these are nothing but the attributes of the class, as we discussed in the prerequisite video. So to initialize those attributes, we use the constructor. And one more thing, constructor does not return anything, and also the name of the constructor is same as the name of the class, and it is get automatically invoked when we create the object of the class. So if you didn't get it, don't worry, I'll be showing you practically. So let me create a constructor. As I already told that constructor has the same name as the class has, and constructor does not return anything. That's why I haven't given any return type to it. It's like a normal function. It can take some arguments. Now it will take some argument, like it will take a value that we want to store in this data compartment, and it will take some address of the next node, which we will store in the next part. So in the data part we'll store the value, and in the next part we'll store the address. So this is our constructor we created. Now let's try to create one node. How we can create a node? We can create a node using dynamically allocating the data or the dynamically allocating the memory. Now here comes the concept of the dynamic memory allocation, like how to do it and how like a dynamically memory is allocated, and what exactly a dynamic memory allocation means. The dynamic memory allocation means allocating a memory dynamically, or we can say at the runtime. So each time when you declare a memory, that will be on a random place in a main memory, and basically not in a, the main memory has some like parts. It may have a stack, it may have a heap. When we declare a variable dynamically, it get allocated inside the heap. So initially we will first declare the head pointer, because we know that the head pointer is very necessary when it comes to the linked list, because that is the only pointer which will help us to traverse the complete linked list. And how we will see that. So I created the head pointer. Now now let's take a look at like how to declare the memory dynamically. If you want to, like, let me give you an example with this. I will say dynamic memory allocation. So what is difference between a static memory allocation and a dynamic memory allocation? So yes, there is a difference. And what is that difference? When you statically declare the data, you don't have complete like hold over that. Means you can change its value, you can like modify it, but you cannot delete that allocated data by your own. But when you declare memory dynamically, you have access to like release that memory by your own using the program, and that we do using the delete operator. Now we also have a new keyword using which you can dynamically allocate the memory. How we declare it? It is very simple. As we know that how to declare a variable statically, you declare it like this. But when it comes to like dynamic memory allocation, you cannot directly give the name to that particular memory location. You need to store the address of that location into the pointer. So we will create a pointer of type integer, and we will specify here like what kind of data we want. So what this syntax means, that we require an integer variable in a memory dynamically we want to allocate, and its type is integer. You can also give initial value to it. If you want a variable with a value 12, and its pointer will be there in the n, and if you try to like print the value at n, this is basically the value at n, it will print 12 only, because we request for the memory in the heap, and we stored 12 inside that memory. So you can see that 12 has been printed. It simply means that we got successfully a memory. It is like a request to the like CPU that I want this memory. Now let's take a look at how to delete this memory. You can delete using this pointer or the memory that we allocated using this delete keyword. So after this, that memory will be released, and now we don't have access to that. Suppose I want to print n to it, it may get printed. Let's see what happens when we like try to do this. So you can see that the garbage value has been printed. It simply means that the n is released. The address will be still there in the n, because the address of that particular memory location has returned using this particular function, and that has been stored into this pointer, and we printed that and we got the 12. But now when we deleted it, we are still having the access to that particular node, but the value that we stored in it have been released. It simply means that the dynamically allocated that variable have been deleted. So this is how we do dynamic memory allocation. It is very simple. It is like kind of the same that we do in the static memory allocation, but there is a difference. Like here we are having we don't have the variable name. We have a pointer in which the memory address is stored, and using that address we can like modify that variable, but the major difference is that the only difference is like we are having a complete like access to this those variable which we declared. Why? Because we can delete those variable after our complete use. So this is basically the major difference. What happens in the static memory allocation, whenever the program will get ended, then and then only that particular like variable will be get released, so that the compiler will handle those. But in this case, dynamic memory allocation, we handle those things. So I hope you understand what exactly the dynamic memory allocation is. Now let's try creating our linked list. So here we have created this head pointer. Now this head pointer will be the starting of our linked list. Now we'll dynamically create a node in which we'll store some data, and we'll assign the address of that node to this head. Since head is a node pointer, we can directly store the address of type basically this node into it. So I will dynamically allocate this, and suppose I'm storing 1 in it, and at the end I will store null, because this is our first node. There will be no more node in it. So now now using these two lines, what we created this head along with this node, stored 1 in it, and cross means null in this section. So we created a linked list with a single node. Now let's like add some more nodes in this section. So how we can do that? Since head is our like starting, this is our head. Just a second. So yeah, this is our head and it is pointing to this node. If you want to allocate this वाला node as well, तो इस node को allocate करने के लिए we need to store the address of this node into this pointer. And how can we access this pointer? In the prerequisite video, we see that how to access the attributes or the functions using this arrow operator. Like if you don't have a actual object, but you have the pointer to that object, you can access the attributes of that object using this arrow. So the same thing we are going to do here. So you know that head is having the pointer to the node. So in the next compartment of this node, basically this node, in the next compartment of this node, like here, we'll store a new node. So we can store a new node with value suppose 2, and I will store null again at the end. So what we have did till now, we have created the linked list of 2 size. It is having this node and this node. We'll create in same way, we'll create this one and this one node as well. Now how we can create? We need access of these next pointer to create this node and create this linkage. So since we know that head is pointing to this, so we can access this using the head next. Now since this is having the address of this node, we can say head next, because head next will be the address of this one. So if you have the address of this node, you can do next and access this one. So we can do head next, and can store the data 3 and null in it. In the same way, I'm creating one more node, and that I can do simply like this. I'm storing 4 in it. So like it says, like, is there any kind of problem? Node to node pointer exists. No suitable conversion from node to node pointer, it says. Yeah, basically I didn't give this new keyword here, so I forgot to give it. So I have given this new keyword here. Yeah, so now we are having a complete linked list that we see here. This with the 4 node, 1 2 3 4. We can also count here. So first node, second node, third node, fourth node. Now how would like we know that our linked list is created? So for that purpose we need to traverse it. So for the traversing the linked list, I'm creating one function here, like I can say traverse, or whatever the name you want to give, you can give it. And let me give you one like advice, that you can study this linked list very well by coding along with me. If you're watching this video, you can code right now along with me, so that you will remember like how the actual process works and how practically the linked list is implemented. So yeah, to printing the linked list, as we discussed earlier, that we only need this head pointer. Okay, so head pointer we need to pass the head pointer when we want to like print the list. So I will pass this head pointer to this one. So I will say I need a head pointer here. Now I can simply here print this. How I can print? I can do a while loop. I will apply this while loop and I will say until the head is not equals to null. You can say 0 as well, because 0 is nothing but a null, but I will say null. So now what exactly this condition means? This condition I said because what I will be doing, because you can see that head is nothing. Here we are passing the copy of this head. We are not passing the head by reference. If we could have passed the head in by reference, we could have written like this, pointer to the pointer, but we don't want to pass like that. We are just passing the copy of the head, so that our actual head will not get affected. So that's why I'm directly writing like this. But if you are doing this operation like here itself with the head, so you don't do directly, don't modify the head, because head is the key to traverse the complete linked list. You can copy that data in like this node pointer temp head, and now you can change or modify whatever you want to do with this temp. You can do it. So since I'm passing a copy to it by value, I'm passing it, so I can simply change the value of it. So I will say see out the data at the head. I'll explain you what I'm writing. I'm giving space here, and also okay, I need to give semicolon here, and I will do head equals to head next. So what exactly this means and what exactly is happening here? So first of all, I have given this condition that until head is not null, because initially you will see that head is null, but I am calling this function at this moment at the 27th point, and at this 27th point our head next is not null. You can see that head next is not null. Why it is not null? Because in the head next we can see that this address is present in the head next. We can visualize that particular array here. In this head next there is no cross. Then since there is no cross, what we will do, we'll simply print this data and move this head to this B. Now this head is not pointing to A anymore, it is pointing to B. We'll see if head what we'll do, we'll see that first like head next is null. No, because there is something, and what that something is, it is nothing but the address of this C. So this is not null, so we'll print this B and we'll do head next. So head equals to head next basically. So now head is not pointing to this B, head is pointing to this C. Now head is pointing to this C. We'll again check if head next is null. So we can see that head next is not null, it is pointing to D. So we'll simply print this C and we'll again move this head to the D. So what we are actually doing, we're doing nothing. We are just traversing this linked list one by one by incrementing this head to next and checking each time that head is null or not. Because at this moment you will see that head will become null, because you will do head equals to head next, and head will be stored with this next and it is having null. So eventually the head will be having null and our condition will true and the loop will be get broken. So this is what we are doing to traverse a linked list. Now yeah, I hope you got the logic, like what exactly we're doing. You can now see by calling this function. What is the name of the function? It is a traverse. So I will do traverse head, I will call it simply, but I'm seeing one error, and what that error is, let me see. I need to pass the head pointer, and that's what I did. Identify traverse is not defined. Yeah, because basically it is not a it's not a like a normal function, it's a function inside this node. So this function can be called using the object of that, basically the object of that particular class, because that is not publicly available. We cannot directly call it, it's not a normal function. So what you can do, you can simply do like this, because head is nothing but the pointer to the object of the type node. Now let's try to run this code and let's see what happens. So you can see that our linked list is printed 1 2 3 4. It has been printed on the screen. So yeah, successfully we created our first linked list. Congratulations to you for creating your first linked list in C++ programming language. And I hope you guys understand the concept of linked list, and you also like understand what exactly linked list is and how to create it. And in the later video we'll see the operations on the linked list, and like how actually linked list is implemented in the like system. I know that you will not require to basically implement the linked list every time when you want to like use linked list, because it is already implemented in the standard template library. There is a like data type whose name is, let me first include this beat slash stdc++, because it's like a global library. It is having everything for you already implemented, beats slash std c++.h. So yeah, now in this stl it is all, there is linked list is already implemented. And how you can access that list is, you are having this, you can create a list like this list. Suppose I want a list of integer type, so I'll give it a name of ls. So this is how you can create a linked list. And ls.pushback you can do. Pushback means simply insert at the end. Insert the data at the end. So if suppose I want to push back 1 in it, I can simply like push 1, again I can push 2, again I can push 3, and so on, like whatever the amount of data I want to store in it. So if you want to traverse it, you can simply traverse it using the for each loop, or like you cannot access it directly, so you can traverse it using the for each loop. Now what is a for each loop? You can do simply do like this. It's like a for in loop in the Python. So ls, and you can like simply print the whatever the it is there. So this is a extra like this. So yeah, so this is a linked list which is pre-implemented in the stl, and how you can print it. This simply says like by reference I'm passing this it so that the copy will not be passed here, but you can also do like this as well. This simply means auto simply specifies the kind of data type. You can also say the int, because we are knowing that the linked list of type int. So one by one each data item will be passed as this it, and it will be get printed on the screen. ls means the name of the linked list. Each time this it will this simply means it in list ls, it in list ls, same as that of the Python. Now let me show you by running it. It will print the same the list that we created using the linked list. So yeah, you can see this is 1 2 3 4, and they are non-contiguous basically. So you can also verify that by printing the address of each node in this linked list. So yeah, I hope guys you understand the whole concept of the linked list. Now our last topic remaining is the difference between the array and the linked list. So let's see what is the difference between array and linked list. Size of the array is fixed, as we have already discussed that the size of the array is fixed. We cannot change the size of the array. Either if we want a large size of array, we can declare it and then we can use according to our need, but that is not the efficient approach. So instead of that, in the linked list case, we are having the variable length of the linked list. It is not having fixed length. Whenever we want to add some more elements, we can add at the end, at the middle, at the head, at any position we want. Now in case of the array, since it is fixed size, it is allocated in the stack. The memory is allocated in the stack, but when we allocate the memory dynamically, it is getting allocated to the heap. Okay, it is necessary to specify the number of elements during declaration. Means in case of the array, it is necessary to specify the elements in the square bracket. When we write the array declaration, we write the number of elements at the time of declaration. If we are not specifying that number of elements, we specify the initialization, like in the curly braces we say that 1 2 3 4, these are the elements that I want to store. So if we will not provide that size, it will calculate automatically from the number of elements given. But if you are not writing the size of the array and you are also not initializing with them with the curly braces, then it will give error. So it is very necessary to tell the size of the array at the time of initialization. So it is not necessary to specify the number of elements during the declaration, because memory is allocated dynamically, that is during runtime. It is not necessary for the linked list to specify the number of elements. it occupies less memory than a linked list for the same number of elements. Means if you want to store 1 2 3 elements, but array will occupy only 3 elements. Means suppose it is kind of integer, so integer is 4 bytes, so total 12 bytes will be occupied. But in case of the linked list, 12 bytes will not be occupied, more bytes will be occupied, because along with each data we are storing a pointer, so there will be large use of memory in case of the linked list. So now inserting new element at the front is potentially expensive because existing elements need to be shifted over the make room. Means in case of the array, when you want to insert element at the front, you need to shift all the elements from first position to the nth position to one shift ahead, so that we can insert that element at the starting. But in case of the linked list, you don't need to shift any element at the like front in the ahead, but instead of that you can easily insert the node at the head. In the upcoming lectures we will be learning about all these operations, that how to insert at the end, how to insert at specific position, how to insert at tail, so how to insert at head as well. So then you will get a clear idea about this point. Deleting an element from an array is not possible. We cannot delete any element from the array. If we don't want to use, we will not use that element, but we cannot delete it. But in case of the linked list, we can delete. So this was the difference between the linked list and the array. Now finally, let's see the question about the linked list. Since we have just studied the linked list, we can solve this question easily. This question we can see on the HackerRank platform, and I'll also be providing the link of this question in the comment section below or the description section. You can check it out, and you can also go here and solve this question. So let's see what is the question. This is to practice traversing a linked list. Given a pointer of the head node of the linked list, print each node's data element. Means we are given with this head, which is the head of the linked list, and we have to traverse the complete linked list. So if the head pointer is null, indicate the list is empty. Means it may be possible that this head pointer will be empty, so we have to handle that case. Now function. So what we have to do here we can see that there is a header file included and some reference code is written, and this is the function that we want to complete, because all other things are written here. We don't have to take care of all these things, like taking input and all. We are given with the head and we just have to traverse it. So input format is like this. First line of input contains n. Okay, these input formats are not of our use, because these are for this int main and they are already handled, so we don't care about that. Our task is to complete this function. Print linked list has the following parameters: single linked list head, a reference to the head of the list. So we are given with this head and we have to just traverse it. We just see the code of traversing the linked list and we will be using that. So what happens in the traversing is, until the head becomes null, because the last node points to the null. So when the head will become null, we will stop the while loop. So what we will be doing here, while head is not equals to null, will print the data inside the head, because we are moving the head here. See, if it would have been the original head, we will not have means we would not have moved it, but this is just a reference to the original head. Original head is here somewhere. This this is the original head, but this is not getting passed as a reference. It is getting passed just as a copy of that head. So that's why we can move this head and it will not affect the original head. So we can simply print like this. Since you can see that the new line character is there after each number printing, then we can move the head to one place ahead by doing head equals to head next, like this. And let's see now if the code runs. It should run. And you can see that all the test cases have been passed. Let's try to submit this. So all the test cases have passed. So you can also try this question. I will share this link into the description section. So thank you so much guys. I hope you enjoyed this video, and let's meet in the next video.